welcome today. So today we are going to be working on Proteus, the simulation software. We are going to be working on something very important, and that is power supply. Now, what is power supply for? Power supply is a kind of AC to DC converter, because most of electronics that we use at home actually works on DC, that is direct current. So the power supply system actually converts the AC that is being given, that is being generated, down to what the DC that is being needed for your appliances, for your device. For example, just like the laptop and some TV sets, some other appliances make use of what the DC. So now it follows a sequence of process. First of all, the alternating current AC from the power source is being turned to what? You step down the voltage. Like in Nigeria where we are, we make use of 220 volts AC at 60 Hz frequency. So we get a step down transformer that will step down this voltage from 220 volts. If, for example, I'm using a power supply for 5 volts, like the one of our charger, of our electric chargers, the phone chargers. So that is transformer that will step down this 220 volts down to 5 volts AC. Now after doing that, it is being passed into a rectifying diode. That is a diode bridge that comprises of 4 independent diodes. After this, it is being passed to the capacitor, which does filtering. Then when this is done, then we'll pass it to a voltage regulator, which actually regulates, makes this voltage stable to give us 5 volts. So today we are going to be giving us this demo using what? Our Proteus software. So let's open our Proteus software. Okay, now remember, after watching this video, you can like our videos, comment on it, share it, and also, very importantly, subscribe to our channel. So remember, this is what the SISAKEST group. So thank you very much. See you after the video. Okay, so the Proteus design suite environment has opened. So we are going to be doing a new project. So initializing the project wizard. Okay. So we have a project name, so we can call this supply power. Okay, so yeah, then we just make use of, okay, we should not create schematic. Okay, let's use the default 7. We don't need PCB for today. No firmwares are needed. Okay, let's finish this and see our environment. Okay, so this is our workstation. So the first thing we are going to do is that we first of all get those documents, the devices, the components that we need coming under this component view. We choose P meaning that we should what? P component. So by the time we come to this place, what are those things we need? We need first of all a voltage source, and that voltage source is what? An alternator. So write it alternator. So this is our alternator. Okay, so you double click, it appears at the side of the screen. So choose the next thing we need. We need a transformer. So we have different type of transformer. We have, you can see them. This is single primary, double secondary. That is like multiple winding. So this is the one we need. So this is another one. It's a center tap transformer. This is a multiple winding transformer, so and so many others. So we use this simple transformer. Double click. The next thing we need is actually a diode bridge. Diode bridge rectifier. So wow, spell which one way. Okay. So we have various diode bridge here. So let's use the diode bridge of this. So the next thing we are going to make use of, a capacitor. Okay, couple. Electricity capacitor. So let's see capacitor. Which one should we collect? Let's make use of this. Okay, so you get that needed. Okay, I guess this is okay for now. Then we need a voltage regulator. So since we are going to be working from, okay, let's make it a 12-volt power supply. So we'll say we need 78-112. So 78-112 is a voltage regulator that regulates the voltage to 12 volts. So let's go with this. So the 78 series are voltage regulators. We have 7805, 7809, 7806, 7802, 112, so and so on and so forth. Okay, now let's start this way. So go first of all with your alternator. Then go over to the transformer. Then move to the diode bridge. Move then to the capacitor. Make it vertically. And then the voltage regulator. From the voltage regulator, you see something. You see voltage in, ground, and output. We are going to show you how we are going to do that. So connect the wires together. Okay. Connect this to this point. Connect this to this point. So AC enters into this point, and by the time it's coming from the diode bridge, we are getting a DC. Connect this to this point. Connect this to this, and connect this to this. Okay, this is what we have. So after this, we need to specify the component we are using, like this. Double click on the transformer. We have transformer 1 telling us the value. We have primary inductance 1H, secondary inductance 1H, that is 1 Aries, 2 Aries, that is 1 Aries. So now what we are going to actually work upon is that we change the coupling factor. So the coupling factor will be the secondary the secondary voltage divided by the primary voltage. So we want to change 220 volts to 12 volts. So say 12 volts divided by 220. So we have 0.05454545. But you know that transformer have its own inefficiencies. So because of that, let's make the 220 240. So it's going to be 0.5. Okay, now let us specify our alternator. The alternator, we have the amplitude of amplitude of 6 volts, but in Nigeria we are making use of 220 volts. So if we make this 1 Hz, it means that this is actually going to be just one frequency, but in Nigeria make use of 60 Hz. So let's see how it's going to be like. So let me simulate this to see what it's going to be like. Okay, based on now we are not able to see what is actually really happening. So the best way for us to see these things is for us to get some voltage, some meters to be able to measure what is happening. So let's go to our instruments. Now let's make use of AC voltmeter, which we are going to put here to measure what is happening. Put it also at this point to see the AC that is being converted. So get our DC voltmeter, which we are going to put at the end to see the voltage that is coming in, that is coming out from the whole process. Okay, let's connect this to this, 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 connect the ground to this, connect this to this. I guess it will be better for us to bring this thing closer so that we'll be able to have some space so that we can zoom it upward. So we are just trying to minimize the space on the screen is consuming so that we can be able to zoom it closer to ourselves. So let's remove this external. Okay, so we're just trying to work on the whole space it is occupying on the screen right now, so that we can reduce the whole space of the power supply system. Delete this, delete this, delete this, delete this, delete this, delete this, so we can move this one upward this way. So join it with this, join this end with this, then we can move this one forward. Okay, so this end, so I need this place to be deleted. So I need this place to be joined with this. Okay, you have achieved that. So let's zoom to the areas so we can have a close examination of this. So let's start. Now by the time we place the simulation, you see what we are getting. Okay, so from what we can see that actually our AC voltmeter is capturing 116 volts, but although we should know that it should not be able to capture it perfectly because the AC is constantly changing. So let's try to work on that. Let's make it easy to capture. can see that as I've changed the frequency, it is showing me the fluctuations. So let's pause again. Let's change the coupling factor of the transformer. Because of the inefficiencies of the transformer, let's see what we are going to get. Okay, so I guess we are going down, not up. So let's pause this. Let's take this to 65. Guess for my calculation on this should be around 0.9. Let's see how it's going to be like. Wow. So we are almost close to the value. We should work on this capacitor. Let's make it 1000 and see the effect of that. I guess the problem was the capacitor there. Okay. So let's increase this frequency to 50 Hz. Okay. Wow. So the system was not able to capture that. Let's try 60 Hz. Because of the transient time was actually very low. Okay, let's try this again. excessive CP load. Wow, so the CPU is having its own problem. So let's take it to one so that my system can be able to capture that effect. So this is what we get. So at the end of everything we get this, that we get 12 volts AC, 12 volt DC coming outside the voltage regulator. So this is how a power supply system, the circuit diagram of the power supply system look like in a real case scenario, and this is how it's supposed to work. So I hope you enjoyed the video today, and remember to subscribe to our channel. Remember to subscribe to our channel. Remember to subscribe to the channel and like our videos. Comment on it also, and also give us thumbs up if you like what we are doing. So remember, the name of the channel is the SISAKEST group. So thank you very much. See you till next time. Bye bye.